Okay, so I gave you a review of what I have done the last time. We are still sharing this one, I think. Okay, so let's look at a few more gear trains, and then we will go on with the planetary gears. Now, for example, one more gearbox, a simple gearbox is this one. Here you have an input, and what will be the output? Output will be in the same direction, I guess. Okay. As you see, there is a compound gear drive here, which takes the input and transmits it to the output. It goes back to the same direction, but it depends on the number of teeth, of course, the velocity. But it's usually, if you have such a gearbox, you usually save from space. Now, there are also gearboxes that change the speeds. There are multiple gearboxes like this one. Let me copy this, and then I will work on this a little bit. On the Microsoft Whiteboard. So on this Microsoft Whiteboard, let me paste this. I couldn't paste. Okay. So we have a complicated looking gearbox. It's not that complicated actually. You will see that basically what it does is the following. For example, here we are not numbering the links, we are numbering the gears. So this is the pulley is 0. This is the first gear, second gear, etc., fourth gear, fifth gear, etc. Here we have, for example, if you have 4 and 5 are connected, okay? This 2 and 8 is connected well, it's confusing. They are not really connected here, okay? 2 and 5 are connected. And then we go on this shaft, on the on this shaft, 6 and 10 are connected. Okay, only. So the output is omega out over omega in would be. Well, again, -1 to there are 2 gears. 22 is the driving, and then 23 is driving, right? Here you have driven is 34, and then 46. Well, this cancels, this becomes 2, this becomes 1. And you can say that this is 11, this is 1. So 11 divided by 34, isn't it? Which is 0.232, something like this. So in this case, you will have output will be 0.32 of the input in terms of speed. And torque will be 1 over that. The torque will be increased. And well, by relocating your gears, you can find different possible connections. For example, if this is your input shaft, let's say, for example, you can engage 3 and 7 here. That's one possibility. 3 and 7 gears, okay? This gear and this gear can be engaged. And out of that, it is possible to engage, for example, when 3 and 7 is engaged, you can engage, for example, in the second shaft, 6 and 10 might be engaged. And the result is 0.257 is the gear ratio. On the other hand, from 3 to 7, if you engage, let's say, not that, but let's say 7 and 11, the speed ratio would be 0.504, okay? And another possibility is you can engage 4 and 5 in the first 4 and 5, just as we did here. So you can engage here 2 possibilities again. One is, let's say, 610. The other is again 711. In this case, the ratio will be 0.323. This will be 0.48. Okay. 2 to 8 is a possibility. 2 to 8, just as we see here. Okay. In this case, these are clutches. You can disengage these using the clutches. Okay. That is, if you engage, for example, 2 and 8, you can disengage 4 and 5. So only one is engaged. Yeah. You can have from 2 to 8. You can have again 6 to 10 or 7 to 11. In which case, one last thing. Let's do it this way. And you can engage 1 and 9. 1 and 9 can be engaged, for example. In which case, again, 6, 10 will give you 0.5 and 1.15. As you see, in this gearbox, starting from the gear ratio of 0.25 up to 1.15, you can have about 10 different speeds by engaging different gears. Okay. So 10 possible, let's say, speed change. Let's change is possible. Okay. Here you have this would be the intermediate shaft. These are the final results, as you see. Okay. So it is possible to have a gearbox with different well, engagements. And as you see, as I have told you, these are clutches which allow you to engage or disengage gears just as you have in the gearbox of your car. There are certain clutches, the debriyage that is, that allows you to change the gear ratio. Okay. So this is a simple gear train, but it is possible to change the gear ratios. Another possibility is, let me copy this from, again, Enes Hoca. Okay, this is an automotive transmission again. Now there is a shaft coming from the engine, as you see, which comes from here. By the way, I didn't tell you the last time, these things like, 19, 22, 23, 34 were the number of teeth, okay? It was not very clear maybe. Here also, for example, this gear has a 14 teeth, this one has 20 teeth, etc. And here there's a clutch, for example. Now, here, the gears is as follows, the gear ratios. In the case you have low gear, that is slow speed, okay? So the output over the input would be, in this case, 3 meshes with 6. 3 would be meshing with 6. And 1 would be meshing with 4. So I should say 1 meshes with 4, and then 6 meshes with 3. Okay. So it goes like this. From this one, this rotates the following shaft, and 6 is connected to 3, which goes to the wheels. Okay, and the clutch is here. This is disengaged, so that the driving teeth is 40. Again, -1 to 2. 14 is driving, 31 is driven, and 18 is driving, and 20, yes, 18 is driving, driven is 31, and 27. Okay. Which gives you a speed ratio of 0.301. Okay. This is the first gear of the car. Now, in the second gear, you will have again 1 to 4 plus, in this case, 2 would be meshing with 5. So 5 to 2. So it would be omega out over omega in would be, again, minus 1, 2 squared. Again, 14 over 31 divided by 25 over 20, which would be 0.564. Okay, now well, it is this might be a direct drive. For example, the clutch is engaged here. In which case, you know, the engine, the shaft coming to the here is directly connected to the shaft that goes to the wheels. So omega out will be equal to omega in. So in a way, omega out over omega in would be 1 in this case. Okay, there is no speed reduction. Okay. And one possibility is it is possible to have a reverse gear here, which is the following. There are only, it seems there are 3 possible gears here in this gearbox. In the reverse gear, what you do is three meshes with 8 and 7. Well, I should say the following. Again, 1 meshes with 4. 1 to 4 plus you have 7, 8, and 3. Okay. Well, what is the point of 8? 8 basically is this one is the idler gear. Okay. It changes the direction. That is the point here. So omega out over omega in would be well, minus 1 to the power 3 in this case. Okay. Again, you have 14 over 31, which is 1 to 4. And then you would have 14. These are both 14s. Well, 7 is 14. So 14 over 14. Then you have 14 over 27. Okay. 27 is the third gear, which goes to the wheels. So the result is minus 0.234. See? Which means that the direction, this means that the direction changes. How does this happen? It happens because of this possibility of existence of this idler gear. Okay. Okay, so these are simple gears, not planetary. I try to explain them Well, to a certain extent. Do you have any questions about these? So the gearboxes are devices in which we transmit power and change the speeds. And also we have possibility of different speed changes by engaging different gears. Any questions about these? If you don't, let me wait a little bit. Anything that's not clear here? All these are transparent and okay? Okay. Then if you don't have any questions, I will continue with planetary gear trains, which are a little bit more complicated than the simple gear trains. Okay. In this case, as we have discussed before, axis of one gear is not fixed, okay, which is called the planet gear. There is the sun gear, there is the planet gear, and then there is the arm. How do I draw this? Just a second. Let me try to draw one planet gear. That's a good one. Okay, the problem here is it automatically makes these shapes. Suppose that this is a point of contact, okay? Let's say that this is our sun gear. Okay, sun gear has a fixed ground. It is grounded like this. Also, the arm is grounded. This is the sun gear. This is the planet gear. And this is the arm. Okay. Let's say that, let's use the notation in our book. Let's say that this one has a radius of Rj. This is the jth link, okay? The planet is the ith link, so it has a radius of Ri. So this is the ith link. And the arm, which is another link, is the link K, okay? And let's say that now these rotate with omega 1i, omega, or you can say omega I. Omega 1i means omega of ith link with respect to the ground. And this is the arm rotates with omega 1k. Arm also rotates, by the way. And this thing, the sun gear, rotates with omega 1j. Now, one important thing is that the degree of freedom of this gear train, okay, is not 1 anymore, it is 2. There are 2 inputs. Inputs are, for example, omega 1j, omega 1k, and the output, for example, will be omega 1r. That is, the rotation of the planet gear will be the output, but the rotation of the sun gear and the arm will be, well, the inputs, okay? So there are 2 inputs. One of them might be fixed. For example, you might fix this one. Let's say might be 0, but it doesn't have to be, okay? So there are 2 possible inputs. So this is a external mesh for a planetary gear train. This is an external. Another possibility is an internal mesh. Oh, sorry. Let me again try to draw a circle as well as I can. It's not bad. Okay, in which case the internal somehow didn't. Internal gear train would be something like this. Again, there is an arc which should be more straight than I drew. Okay. So it is rotating inside this gear now. Now it is not called the sun gear anymore, but it is called the ring gear because it's like a ring. It's hollow inside. So ring gear is J again. The arm is K. And here this is also still the planet, which is again I. In this case, still you have the degree of freedom is 2. This is called an internal mesh. Okay. Any questions up to here?
Hocam, how did we get degree of freedom 2?
Well, if you analyze it, this is what you are going to get, but you see, we have 2 inputs here. That's the thing. Well, we can analyze it and find that degree of freedom is 2. But you can see directly that both the sun gear and the arm can rotate in order to make the planet rotate. Do you understand? I can analyze the degree of freedom, or you can analyze the degree of freedom by, by having a gear joint here, revolute joints at these points, etc., etc. And you can find that the degree of freedom is 2 here.
Okay, hocam. Thank you.
It's not that difficult. You can do it. Also, let me try to draw this thing, how it would be drawn from the side view. It would be something like this. The sun gear Let me just copy it from, sorry about that. This would be much easier. It takes so much time to copy, draw these things. So let me just paste it. Okay, I don't know if you can see it well, but at least you can see these parts kind of well, okay? Let me try to draw this a little bit better. This is the planet. This is the sun here. It's not very well seen here, and there is the arm. So this is the original drawing, okay? Sun gear, planet gear rotates around it, and the side view is like this. There is this is the planet gear, as you see. Sorry, the sun gear. This is the sun gear also. The sun gear has a certain shaft. Now, the planet gear rotates around it. Okay. Now the arm is wrapped around the, as you see, the planet gear. This is the planet gear. Okay. The blue one, and the arm makes the planet gear rotate around the sun gear like this one. Okay, so it makes a complete rotation. The speed of the arm can be, modulated, can be omega 1k, and here you can have omega 1j, and the speed of the ith gear is going to be, well, changing according to these speeds. Okay, so it will be rotating around. Now this is the an external mesh, as we see. For the internal mesh, you have something like this. It's not very clearly seen, so I'm drawing it again. So this is the ring gear, this one. Here, the red one is the ring gear. It has a fixed, well, it's not fixed, its shaft is, well, maybe this is a little bit. The ring gear can also, should be able to rotate if necessary. So the planet gear, which is the blue one, rotates inside the ring gear now, okay? With the help of the arm. This is the arm. Okay. I hope this is more or less clear. The physics of it should be clear now, isn't it? Let's try to analyze this. That is, how is the angular velocities related to each other? That's what we will try to find out. Again, let's try to draw a external mesh. Better one, perhaps. Anyway, again, the point of contact, let's call it P. The velocity at the point of contact should be the same. Let's call this point A. So this point is A. Okay. So you have omega 1j. Omega 1k is the arm velocity, and you have omega 1r. So j is this one, k is the arm, and I is the planet. This is rj, this is ri, etc. So the point of contact P, Vp, which is the point of contact, is the same for Vpi, and that is Vpj. Okay. Both for the sun and the planet, you have the same velocity. By the way, you should note that P is not on the arm. Okay. P is the following point. This is the point P. Or this is the point P. Okay. It has nothing to do with the arm. Okay. What is the velocity of point P? We know the following. Velocity of P should be equal to, since this is rotating, looking at from the sun gear's point of view, it is omega 1j times rj, isn't it? So the velocity of point P, which is this point, has to be equal to, this is, if this is Vp, that velocity has to be, well, gear's angular velocity, which is omega 1j, times its radius. Okay, it's clear. Now, also the velocity of point A, let me write it in this one, VA, this is from the planet here. Sorry, not planet, the sun here. VA is shared by, the A point is shared by the arm and the planet, but from the point of view of the arm, it is the arm length, or I should say omega 1k arm velocity times the arm length, which is rj plus ri, because up to here it is rj and then it is ri. This is in terms of the arm length. Okay. Well, I guess we are getting late. I think we should take a break here. I will continue in about 10 minutes. Okay. So let's take a break at this point. Well, let's stop and pause the recording. So we are analyzing the external planetary gear. So the velocities of points P and A, we can find out. So this is velocity of point P. Let's say that this is velocity of point A. Okay, velocity of point A has to do with the arm's velocity. Point P is shared by I and J. Point A is shared by I and K, as you see. Now, another thing, this is the crucial thing actually, we can write the following. For the planet here, we can write the following relative velocity equation. We can write Vp is equal to Va plus Vp relative to A. And this we write for the planet here. That is, for the planet here, let's say this is the planet, okay? This point is P. This point is A. Each of these points have a certain velocity. This is, let's say, Vp. This is Va. But there is also Vp relative to A. Okay, what is this? Vp relative to A means the following. This is the Vp when A is fixed. I shouldn't say maybe when, but Vp when if A were fixed. So it is something like this. Again, let's say we fix A. This is, let's say, omega 1I. Okay. A is fixed now. This point velocity of P would be Vp relative to A in this case. This is A, this is P. And the velocity of point A would be here, Vp relative to A, as you see, is in the opposite direction to Vp. That's why we put a minus sign there. Okay. So, once you have this, we have Vp, Vi, Vj, etc. We can write again, Vp is equal to Va plus Vp relative to A. So we can write Vp, this one, omega 1j Rj is equal to Va, omega 1k Ri plus Rk minus omega 1I Ri. Okay. In which case we can collect the terms. For example, we have Rj, well, but there is no Rk here, so this is wrong. This is Rj. should be Rj, right? Yes, Rj plus Rn. So I collect the Rj terms, for example, which will be omega 1j minus omega 1k times Rj will be equal to minus yes, that's correct. So we get the following: omega 1j minus omega 1k divided by omega 1i minus omega 1k, which is by the way the velocity of the sun gear with respect to the arm, velocity of the planet gear with respect to the arm. This is equal to, this is minus Ri over Rj. And again, this is equal to minus, because of the gear ratios, this is equal to the ratio of the teeth, and this is what we call Rij. Okay, this is the gear ratio. Well, it is kind of similar to simple gears, only difference being the arm. You have to subtract the arm velocities from the angular velocities. Okay. So this is correct. This is what we get as a result. Let's try to do this, the same thing for an internal mesh now. Oh, that's terrible. Draw a good circle. Okay, this is a good one. Small, good one. Okay. This is the arm. Okay. So this is J, this is I, this is K. Now, this point of contact is P. Sorry. Okay. I don't know, something was wrong. I guess, can you see me? Can you see me now? Anybody? Okay. Something was wrong, so I tried to correct that. Let me start sharing the screen. Okay, so the internal mesh, hopefully this won't be in error again. Uh, Okay, again, we have write the velocities of P and A. Velocity of P will be omega 1j rj. Okay, so then something is wrong. Hopefully this won't be a problem now. Just a second. VA is on the arm. This is on the ring gear. On the arm you have omega 1k. Now this will be Rj minus Ri because this is the arm length. Okay. And similarly, Vp relative to A here will be omega 1 I times Ri. So if we collect again, Vp is equal to Va plus Vp relative to A. We will write Ri. In which case, we will get the following if you collect the terms. Omega 1j minus omega 1k divided by omega 1i minus omega k Again, this will be omega j relative to k divided by omega I relative to k. That will be Ri over Rj without the minus sign, Ti over Tj, which is Rij, the gear ratio for the internal gear. So in general, we can write the following. The plus is for internal gears, minus is for this. Okay, so I guess this is a little bit more complicated than the simple gearing. It has two variables, two inputs. One is the arm input. An arm input can change a lot of things, by the way. By manipulating the arm velocity, arm angular velocity, you can change the gear ratio enormously. And that is the advantage of the planetary gears. Using planetary gears and the arm, changing the arm velocity, you can change a lot of things about the planetary gears angular velocity. Let me give you an example here. Let me draw this boat in, let's say that this is your sun gear. Let's say this is the planet gear. And this is the arm. So the sun gear has, let's say, 60 tweak. The planet gear has 22 teeth, rather. This rotates with 150 RPMs. Okay. Clockwise. Arm rotates with, let's say, 100 RPMs. This will be counterclockwise. Okay, and the angular velocity of the planet, omega planet, whatever it is, omega 1I, is unknown. We want to find this out. Okay, the theta are given, so the diameters are not necessary for the radiuses. Let me draw this as a from the side view. Let's say this is your sun gear. This is your planet here. And there is an arm. So the sun gear rotates with 150 RPMs. The arm rotates with 100 RPMs. This is the planet. We don't know how fast it rotates. This is the planet here. We want to find its angular velocity. As we know, this is a 2-degree of freedom system. There are 2 inputs and 1 output. Let's try to find out. We will use our regular equation, omega 1j minus omega 1k divided by omega 1I minus omega 1k is equal to Rij, as we know, which is equal to minus Ti over Tj, which is minus 22 over 60. Now, what are these? Omega 1j. Since we are using RPMs, well, we can, if you use RPMs, you can go ahead and use RPMs. Here it doesn't matter really. You don't have to convert it to radians per second. Omega 1j. We are using counterclockwise is positive. Okay, so clockwise rotations would be negative here. So omega 1j would be minus, clockwise is minus 150, okay, minus omega 1k. Omega 1k is counterclockwise, so it's minus 100. Omega 1i, we don't know this, minus 100 is equal to minus 22 over 60. So this is minus 250, this thing, times, let's say minus 60, is equal to 22 times omega 1i minus 100. 15,000 is equal to 22 omega 1i minus 2200. And what will that be? Omega 1i. This goes to this side, so and that will give us somehow I don't have it in my notes. So omega 1i is 781 RPM, and that's counterclockwise. Okay. So its rotation is quite fast, as you see, compared to other ones, and this changes quite a lot by changing the arm velocity. Okay, by changing the arm velocity, you can change the planet gear's possible velocity. You can even change its direction. Yes, by the way, such gears, planetary gears, are commonly used in, for example, in clocks, in watches, for example, because they can achieve very high reduction ratios. Okay. Any questions about these? Okay, well, if there is no question, I'll give you another example, and it is maybe much easier if I copy it again from Eres Hoca. Here we have two planetary gears. Let me, well, draw here. It's not very clear. Here you have an arm. Okay. Now it's a little bit interesting. Now this I J prime K is an external gear. On the other hand, P J K is an internal gear. And here you have this is the arm, and this is the output. And the input would be this one actually. The output shaft, we don't know this direction. We will probably try to find out. Okay, is this understandable? Did you understand what is going on here? The blue gear has, the blue gearing has two different shafts. They are, in both cases, it is the planet, but in the first case, it is the planet to the sun gear. In the second case, it is the planet to the ring gear. So this is the sun, this is the ring gear. Okay, let's try to write this down. For the external gearing, that is I prime, I, J prime, K, you have omega 1J minus omega 1K divided by omega 1I minus omega 1K is equal to Rij, and that is equal to minus Pi over Pj prime. For the internal one, which is, as I said, Pjk, you have omega 1p minus omega 1k divided by omega 1j minus omega 1k is equal to r. This should be rij prime value. So, Well, okay. Since I have written it this way, I have put rjp here. Otherwise, I could have put omega 1. Yeah. Okay. Since j is downwards, this is what I should do. Okay. In this case, what we want to find, I is the input, as you see. Let me write it here. I is the input, and output is the P. So what we really want to find is RIP, which is equal to, you can say Rij times Rjp, right? Which you can write as follows: omega 1j minus omega 1k divided by omega 1 pi minus omega 1k times okay. Nice thing is that these things are going to cancel each other. And this should be equal to so you can say omega 1p minus omega 1k divided by omega 1 pi, which is the relative velocity of the output, and the ratio, the denominator is the relative velocity of the input with respect to the arm, would be minus Tij Tj prime Tp. Since k is 1, this minus sign remains here. So in general, the following is true. Well, this is very similar to what we have seen for the simple gears, okay? For example, you can say the following. RIP, for example, would be minus 1 to the power k driving heat number and k being the number of external meshes here. In our case, this is just one. Now, these planetary gear systems are not very easy to understand, okay? The way it works, the way it is structured. Usually especially for complicated problems, you can easily get very confused. So it is important to get used to these concepts. Let me see what I can do for this. So here, for example, as we see, input is the ith gear. So this drives J prime and J drives P. So Ti and Tj are the driving gears, and J prime and P are the driven. So this is what we get out of this. Any questions about these? I will try to solve some more problems the next time. Let me solve something a little bit more complicated. Let me copy it first, so that I don't have to draw. Again, this is from Enes Hoca's thing. This is a little bit, there is a gear which is both a planet gear to both a sun gear and a ring gear, but the thing is the ring gear is fixed. So omega 1, if you like, is 0. Okay. So the gears are numbered 2, 3, 4. So 2, 3, 4 is an external mesh. And 134 is an internal mesh. Let's try to analyze this. What is given here? By the way, let me just check. So the arm's velocity is clockwise 40 radians per second. And omega sun, which is omega 1, 2, is unknown, which is this thing, which is rotating here. We want to find out the sun gear's velocity, angular velocity rather. So for 2, 3, 4 external mesh, we have omega 1, 2 minus omega 1, 4 divided by omega 1, 2 minus omega 1, 4 is minus T3 over T2, which is R32. And for the 1, 3, 4, we have we have the planet gear 3. We can eliminate its as we see its effect. It's not very difficult. We can do the following. For example, omega 1, 2 minus omega 1, 4 divided by omega 1, 3 minus omega 1, 4, which is this one, R2, 3, okay, times omega 1, 3 minus omega 1, 4, which is this one. I'm just reversing this one. Omega 1, 1 minus omega 1, 4 is minus T3 over T2. And this will be T1 over T3. So T3s will cancel. This will cancel. And what we will be left with is omega 1, 2 over omega 1, 4 divided by omega 1, 1 minus omega 1, 4. As we know, omega 1, 1 omega 1, 1 is 0. What happens? I don't know what's going on. Anyway, let me continue. omega 1, 2 minus omega 1, 4 is equal to T1 over T2. Now let me just erase this. This is 0 is equal to minus 2. So omega 1, 2 minus omega 1, 4 is equal to 2 omega 1, 4. Omega 1, 2 is 3 omega 1, 4, which is clockwise. Okay, so this is the result. This is what was asked, and we find out what it is. Any questions about this? I will go on solving some more problems the next time. Our time is up, so let me stop recording.